Welcome. Now we will study Doppler's effect in reflected sound. This is very interesting and important topics. So whenever a sound is reflected from a nearby wall, the wall act as a plane mirrors, and after reflecting the sound from the walls, it appears to change to the observer. Let us start. This is our wall. Uh, Also called cliff, and this is our rest observer at rest. Velocity of observer, let us suppose velocity of observer at rest, and our source is moving toward the cliff, and this is velocity of the source. This source moving toward the cliff, and since the wall act as a plane mirrors, let us suppose we assume the image of S at the point of S test. We know that if any plane mirrors, the object image is at the same distance as that of the object. If this is the object and this distance, and its image of S is S dash, will be the same from this wall acting as like a plane mirrors. First, the observer receives two frequency of sound, two sound. One is directly from the source to the observer, and another is the reflected sound, which is coming from the image of S at the point of S test. So these are the two ones. When these two sound received by the observer simultaneously, it appear to him like a beat frequency. So you already know that the beat frequency is the differences of these direct sound and the frequency, the sound coming from the reflected. Now let us start first the sound which appear to the observer directly. Now let us suppose F1. F1 is the frequency. Frequency of sound directly heard by the observer. Yes. Now we know that observer, the source is moving away from the observer, and observer is at rest. So therefore our apparent frequency will be F1 will be our apparent frequency, and F is the original frequency multiplied V divided by V plus Vs. Since our source is moving away from the observer, therefore our apparent frequency will be less than that of the original frequency. Here F is the original frequency of the sound. So this is our first case. Now this is equation number first. Now the sound which reflected from this cliff coming toward the shores. As I already said that S dash will be the image of S. The reflecting sound coming as from the sources of S dash, from the sources of S dash. Since the source is coming toward the observer, whenever the source is moving toward the cliff, its image, which is S dash, also moving toward the cliff. So it means that the source is coming toward the observer. Therefore our frequency will the apparent frequency will be greater than that of the original frequency. Now second case, F2, frequency of the sound heard by the observer in a reflected sound. Now it means that this apparent frequency obviously will be more than that of the original frequency. Now our numerator, since the source is moving toward the observer, our frequency becomes V divided by V minus Vs. Our numerator should be greater than that of this denominator. Now this will be our apparent frequency. So if these two frequencies is heard by the observer simultaneously, then it will appear there will be some beat frequency. Now the beat frequency will be our beat frequency will be the higher frequency minus the lower frequency. Higher frequency, since both frequencies are different, therefore B2 minus B1. F2 minus of course. F2 has at the value of this one, F2 F times of V upon this V divided by V minus Bs minus and F1 has the value. This will be our equation number 2. This is our equation number first. F times of V divided by V plus Bs. So this is our beat frequency. Now take an F common from here. FB is taken out inside of this one, V minus Bs minus V plus Bs. If I take the LCM and simplify this, I will get beat frequency. Now that beat frequency comes out, taken the LCM, A minus B, A plus B, it comes out A square minus B square, and if go this side, F times of this terms go this side, V plus Vs minus, and should be in bracket, if both this side and outside is minus, and it becomes plus. Now minus B plus B cancel out. Now finally our beat frequency becomes F2 minus F1 will be Vs plus Bs will be twice V, twice F Vs divided by V square minus V square S. So now this is the required beat frequency. Let us do some numericals on this articles. Now we will do some numericals under the previous articles. Now this is the problems. Imagine is emitting a sound of frequency 1000 Hz moves you towards a cliff. This is the sound emitting vehicles moving toward the cliff, and the observer is here. This observer will receive first sound is directly from the source, and another sound will be received by this observer, which is directly reflected from the cliff. Now first case. Now what is the frequency of the sound you hear coming directly from the sun? Now the answer of the first part would be so what would be the, since our source of sound is moving away from the observer, therefore our frequency will decrease. Now since the source is moving away, so our apparent frequency in that case will be this the original frequency multiplied velocity of the air divided by v plus velocity of the source. So now here everything is given here. Frequency of the original frequency of the sound is 1000 hertz. 1000 hertz. Velocity of the source, which is 10 meter per second. Velocity of the source is 10 meter per second. Now therefore the apparent frequency which is heard by the observer is 1000. Put the value of f. Velocity of sound in air 330 meter per second. 330 divided by v, 330 plus velocity of the source, which is 30. Now after calculating, this value comes out 330 divided by 340. If you simplify this one, I will get the frequency approximately 970.6 hertz. If you calculate this one, it comes out 970.6 hertz. This will be our frequency, which is less than the original frequency. When both source and observer are addressed, so our frequency will be unchanging. That will be 1000 hertz. Now in the second part, what is the frequency of the sound you hear from the reflected from the clip? Since the source is moving toward the clip and its image, we have assumed this clip as a plane mirror, then the image of this S will be S dash, and since the source moving toward the clip, and therefore the image of S, which is S dash, also moving toward the clip. Since this imaginary image of S is moving toward the observer, therefore our apparent frequency is more than that of the original frequency. Now answer of the second part would be, we have this is the apparent frequency. Since our source is coming toward the observer, therefore you have to replace V plus Vs with V minus Vs. Therefore our frequency will be V minus Vs. Now if you put all the values here, f will be 1000 and the velocity 330 divided by 330, v 330, and the source velocity is 10 meter. Now it comes out 1000 into 330 divided by 320. Now after calculating these values, obviously will be more than that of the 1000. It comes 1031.3. After calculating value, 1031.3 hertz will be our apparent frequency. Now for the answer of the third part, we have to calculate the beat frequency which is heard by these observers. Since the beat frequency, when two frequencies approximately nearby each other, so when they meet at the same point, then the observer will be heard a beat. That beat means when the sound intensity is increasing and decreasing, it is called the beat. So therefore our beat frequency will be difference of this one. Now we have the beat frequency. Now the third part, answer of the third part would be beat frequency. Beat frequency will be F2 the higher one, F2 minus F1. F2 has the value 1031.3, 1031.3 minus the frequency which comes out in the first part, which is 970.6 hertz. 970.6 hertz. After calculating, this value comes out 13 minus 6 will be 7, and 0, 3 and 13 and 6, and now 9. It comes out 60.7. 60.7 so will be our beat frequency. This is the hertz.